Hello and welcome back. So on the last video, we've been solving exponential and logarithmic equations. So I want to do one more example here. So here we have the log base 10 of x plus log base 10 of x plus 3 is equal to 1. So in a situation like this, the first thing we could do is use our sum to product rule with logs and bring these guys together. And so let's see, we'll write them as the log of x times x plus 3, okay? So now we have it as a single log and we say it's equal to 1. Well, so here then, since it's log base 10, we can just say that what this is saying is 10 to the power of something equals this, and they're saying that that something is 1. So we can just write that 10 to the power of 1 is equal to x times x plus 3. Of course, x, or 10 to the power of 1 is just 10. And so we can say 10 is equal to, and we'll distribute this x. We get x squared plus 3x. And so now, we'll subtract this 10 over here, and we would get x squared plus 3x minus 10 is equal to 0. And so now we have a quadratic equation. And so let's look and see here. Yeah, 10. We could say, well, the factors of 10 are 2 and 5. It's a minus 10, so we'll say, let the 2 be negative and the 5 be positive. That will give us the positive 3 here. And so I'll come up here. And so we can write this as x and x here. And so we'll say x minus 2 and x plus 5. And that, of course, is equal to 0. And so we have x is equal to either 2 or x is equal to negative 5. Now, here what we have to recognize, though, is that the domain of the log, of this logarithm here only goes from from 0 to infinity. So you have to go and look at your original equation. And that's one thing to notice about these, these properties of logarithms. Okay, so when you bring these guys together like this, you can put negative 5 in for x here, and you would get, here's a negative 5. So if you said negative 5 plus 3, that'd be negative 2. And negative 5 times negative 2 would be positive 10. Okay, so in this, having this log, you can put in a negative number. Notice that technically, this logarithm here, this particular function, when you plug this expression into the argument for the log function, yes, the domain of this function is actually, it would be different, okay, than it would be for this one. But see, what you're doing is you're simply creating an extraneous root, and we've seen that before. And so you have to go and you have to look at your original equation and see, well, would x being negative 5 be in the domain of these two functions? And the fact is that it is not, okay? So we would have to throw away the negative 5 and recognize that the only real solution here would be x is equal to 2. Okay, so that's it, I think, for doing these equations. I think you probably have the hang of it. And so now in the next videos, we're going to start talking about kind of, the theory of exponential functions and, what they're actually good for, the properties of nature and actually business and finance, the things that exponential functions model, and why we want to solve them and the things that we can find. So I'll see you in the next video.